Hi everyone, welcome to this week's homework video where we're going to be talking about converting measurements of length and just measurement in general. Okay, so the first thing that we need to focus on is multiplying and dividing by 10, 100 and 1000 because this is very important when it comes to converting between measurements. Okay, so let's talk about that first. So when we're multiplying by 10, 100 and 1000, we've got the rules written here. If we multiply by 10, we move the decimal point to the right once. If we multiply by 100, we move to the decimal point to the right twice. And if we multiply by 1000, we move the decimal point to the right 3 times, okay? So the best way of remembering it is 10 has 1 0, so we move it once. 100 has 2 zeros, so we move the decimal point twice. And 1000 has 3 zeros, so we move the decimal point to the right 3 times. Okay, so let's have a look at what that would look like. If we look at the first question, we've got 57.34 multiplied by 100. So let's write that number out. 57 decimal point 34. Now we want to multiply this by 100. That means we get our decimal point and we move it to the right twice. Okay, so we grab the decimal point and we're going to move it once to the right, twice to the right, and we are left with 5,734 point, and of course nothing there, so we don't have to read that decimal point. So the answer is 5,734. Okay, so let's write that down here, 5,734. Okay, let's look at the next one. So the next one is 17 multiplied by 10. So let's write the number 17 out. Okay, now when we multiply by 10, we move the decimal point to the right once, but 17 doesn't have a decimal point. If the number doesn't have a decimal point, just put one in, put one right at the end, okay, just like that. And let's move it to the right once. So let's move that decimal point. And you can see there would now be a space here. And because there's a space here, we need to put a placeholder in, a 0. And our answer is 170. So let's write that answer down. And then our final question is 0.467 multiplied by 1000. So let's write that number down, 0.467. And we're multiplying by 1000, which means we need to move our decimal point to the right 3 times. So once, twice, 3 times, that's where our decimal point is going to end up. So what number do we have? We have 467. So the answer is 467. Okay, so that's how we multiply. To divide, it's a very similar approach, isn't it? Instead of moving to the right, we're going to move to the left, but everything else is the same. In other words, if we divide by 10, we move to the left once. If we divide by 100, we move to the left twice. And if we divide by 1000, we move the decimal point to the left 3 times. Once again, you can remember this by looking at how many zeros there are in each of those numbers. Okay, so 1 0 in 10, we move it to the left once. 2 zeros, we move to the left twice. And 3 zeros, we move to the left 3 times. So the first question here says 14.35 divided by 100. So we've got 14 decimal point 35. And we're dividing it by 100. So this time we're moving our decimal point to the left and we're moving it twice because we've got 2 zeros in 100. So once, twice. What is our answer? Our answer is 0.1435. Or you can write 0.1435. They both mean the same thing. Okay, and then we've got 58 divided by 10. Okay, so let's write the number 58 down. So 58. Okay, we move the decimal point to the left once, because 10 only has 1 0. We don't have a decimal point, and when we don't have one, we can just put one at the end, just like that. Okay, so if we move that decimal point to the left once, let's pick it up, move it, we are left with 5.8. So the answer to that question is 5.8. Oops, sorry about that, 8. Okay, and then we've got the final question, which is 467 divided by 1000. So let's write 467 out. Of course, it doesn't have a decimal point, so we're going to put one at the end. We're dividing by 1000, which means we're moving to the left 3 times. So once, twice, 3 times. What are we left with? We are left with 0. 0.467 or just 0.467. It doesn't really matter which way you say it. And that's how we multiply and divide by 10, 100, and 1,000. Okay, so this is important as our measurement unit progresses. Dividing and multiplying by 10, 100, and 1,000 are going to be very, very important. So make sure you understand this. Your first task is to have a look at the questions on the screen and give them a go. So what I'd like you to do is give all questions a go. Remember, what I'll do for you is I will remind you that multiply, we move our decimal point to the right, and divide, we move our decimal point to the left. Okay, so that's your reminder. Of course, how many times you move the decimal point depends on whether you're multiplying or dividing by 10, 100, or 1,000, but I know you're going to remember that. So give those questions a go. Now, when you've done these questions, grab a calculator and check your answers. And if you're incorrect with any of the questions, it's very, very, very important that you understand where it is you went wrong, okay? It doesn't matter if you're wrong, but you do need to understand where you've gone wrong, okay? So make sure you give that a go. Use a calculator to check your answers. And once you've done that, move on to the next part of this video. Okay, let's remind ourselves of length perspective. So in exams, particularly exams like the 11 plus, the question that you can see on the screen is very, very common. And the question goes something like this. Which of the following items is most likely to measure? And it will specify a measurement. So it might be, for example, which of the following items is most likely to measure 100 centimeters? And then you'd pick from about 4 objects, and you pick the one which is most likely to be 100 centimeters. So how do we approach those questions without a ruler? Well, that's where length perspective comes into it. What I'm going to do is show you 4 different objects, 4 different items that all have an approximate measurement associated with them. Okay, so that you're able to imagine what different lengths look like. So for example, if you look at the screen, 1 millimeter is about the width of the lead of a pencil. 1 centimeter is about the length of a fingernail. 1 meter is about the size of a guitar. And 1 kilometer is about the length or the distance of someone going for a run. Okay, now, try not to overthink about these examples. You might say, well, what if I went on a very short run or a much longer run? Don't worry about that too much. What I want you to associate 1 kilometer with is the fact that it's a long distance. It's not likely to measure an object. It's likely to measure a distance, yeah? It's likely to measure someone traveling somewhere rather than an object or an item. Likewise, with the other measurements, 1 millimeter, you might get thicker pencils, right? But you won't go far wrong, or you won't go wrong at all, if you always associate 1 millimeter with being very, very, very small, like the width of the lead of the pencil. Again, you can have small guitars, you can have bigger guitars, but just associate 1 meter being the average size of your average guitar. Don't worry about ones that are smaller or bigger. I know we've had that conversation this week. Just try to associate the average guitar with being about 1 meter tall. And once again, with the fingernails, everyone's fingers are different size, but once again, try not to overthink it, okay? 1 centimeter is roughly the size of your fingernail. And once we can remember all 4 of those items, once we have them in our heads very secure, when we get those questions that I showed you a minute ago, they become a lot easier to answer, okay? So one more thing, before we practice that, have a look here. These numbers are telling us how many of each unit is in the next unit that follows. For example, there are 10 millimeters in a centimeter, and there are 100 centimeters in a meter, and there are 1,000 meters in a kilometer. Okay, so just as an example, if you're asked to find an object that is, let's say, 2 meters, the idea or the visual that you should get in your head is the length of 2 guitars. Okay, because a guitar is 1 meter, 2 guitars is 2 meters. And once you've got that idea in your head, once you've managed to paint that image in your head, you can probably compare it to some of the options that you have. Okay, so let's look at an example. The question is, which of the following is most likely to measure 4.5 meters? Okay, so at first, if we didn't have these objects, these items on the left, that question can seem pretty tough. But once we understand perspective, length perspective, once we have a good idea of what each measurement means or what each measurement looks like, the question becomes a lot easier. Okay, so before we answer it, let's think about what does 4.5 meters look like? Okay, there's no point of comparing it to a millimeter or a centimeter, is there? They're too small. But a guitar is 1 meter. Therefore, 4.5 meters is about 4 guitars or 4.5 guitars, right? So what we want to do is imagine in our heads, what does 4.5 guitars look like? Picture that in your head. And it's a bit tricky. It might be a bit vague, but you should be able to deduce some of these answers. So think of 4 guitars standing on top of each other. Is it likely to be the size of the height of a child? No, of course not. It's going to be way too tall. Is it likely to be the height of a mountain? Nope, of course not. Mountains are way bigger than 4 guitars. And the same can be said about the coastline of an island. If you think about an island and its coastline, it's very, very, very unlikely that the coastline of an island is going to be equal to a length of 4 guitars, okay? So it can't be that one. So the answer must be the height of a bus. And if you think about it, obviously don't do this, but if you can imagine a bus on the street, if you were to measure it using guitars, would it be unreasonable that the bus is the same size as 4 guitars? Probably not. So we know our answer is a reasonable answer. Okay. So now that we've done that one, have a go at these 3 questions. Okay, so I won't read them out, but what I'm going to do is I'm going to leave them on the screen for you. So give them a go, write them down. And if you do have any issues with these, make sure that you let me know. You ask me the next time that I see you. Okay, so I'm going to move on from this page now. So if you haven't done this section, make sure you pause it. Okay, so the final part of this lesson is we're going to remind ourselves of length conversion tables. So we've drawn these tables this week, and you might remember how to draw them, but if you don't, I recommend practicing because they're very, very useful. Okay, so this is what a conversion table looks like. Now, let's see how this works. If you look at the table below, we're going to look at the child row of this table, okay? I'm not going to do pen, lamppost, and distance to supermarket. That's your job in a minute. But if we look at the child row, this table is telling us that a child is 120 centimeters, okay? So there's a child that's been measured, and they've measured in length 120 centimeters, right? What we need to do is convert this measurement here into millimeters and into meters, not kilometers. It's blacked out. The reason for that is because measuring a child using kilometers is unreasonable, okay? Kilometers are way too large a distance to measure a child. Okay, so how do we use this conversion table? How do we get these centimeters into millimeters and these centimeters into meters? Let's start by converting these centimeters into millimeters. What we need to do is have a look at this table and find where it says centimeters, which is here or here. Okay, so it says centimeters twice. Now we want to change the measurement into millimeters. So we won't be looking at the top part of the table here, because this tells me centimeters into meters. This arrow is going from centimeters into meters. But if we look at the table below, or the part of the table below, this arrow says centimeters into millimeters. Yeah, so we're using this section of the table because this is where we go from centimeters into millimeters. Now, because we're using the bottom part of the table, it means we are multiplying. That's where the multiplication symbol is, okay? And we are multiplying by 10, because that number 10 comes in between millimeters and centimeters, okay? Because there are 10 millimeters in 1 centimeter. So in order to get our answer, we need to multiply the answer by 10. Yeah, so 120 centimeters times 10 will give us the answer. So 120 times 10. Okay, you can probably do this in your head, but if you can't, don't worry, because remember, to multiply by 10, we move the decimal point 1 place to the right. So if there's no decimal point, put one in, then move it. Okay, so there's our decimal point. We're going to move it to the right once. And now we've got this space, haven't we, where a placeholder must go. So the answer is 1,200. Now we're going to convert from centimeters to meters. Okay. So we know that the child is 120 centimeters, but we want to get it into meters. So let's look at its table. We want to go from centimeters into meters. So this time we're going to look at the top part of the table because have a look up here, centimeters into meters. If we look at the bottom part of the table, it doesn't do that. Centimeters goes into millimeters. It's going backwards. But the top, centimeters goes into meters. And because we're looking at the top, it means we're dividing by 100 because 100 comes in between centimeters and meters. So we're divided by 100. How do we divide by 100? Well, we get our number, which is 120. And to divide, we move our decimal point to the left. And because we're dividing by 100, which is 2 zeros, it means we're moving to the left twice. So once, twice, we have our answer. Our answer is 1.2. You can say 1.20, but 1.2 is a much more sort of mathematically acceptable way of saying it. Because we don't need to express that because we've got nothing there. Yeah, so 1.2. If you do say 1.20, you're not wrong, but 1.2 is a better way of saying it. Okay, so that's the answer. So we had 1,200 millimeters for the child, and 1.2 meters for the child, and 120 centimeters for the child. Okay, so that's why conversion tables are great, because they allow us to do things visually quite easily. Now, when it comes to the 11 plus exam, you won't get a conversion table, nor will you be able to write one. But if you do practice drawing this, eventually you'll be able to see this sort of table in your head. So when it comes to answering these questions, you'll be able to move all the numbers about in your head. So it is worth having a go at drawing these. We've done it this week, so you're more than capable. So maybe you can practice drawing that. But your task for this section is, can you fill in the rest of the table, but not the blacked out parts? Okay, so for pen, we're going to ignore meters and kilometers. For lamppost, we're going to ignore millimeters. And for distance to supermarket, we're going to ignore millimeters and centimeters. In other words, you only have 1, 2, 3, 4 questions to answer in this final section. Okay, give that a go. Thank you for watching and see you next week.